All right, so here's an application problem. It's an age problem. It says Joanne is 22 years older than her daughter Stacy. The sum of their ages is 42. How old are they? Okay, so the first step, I'm going to ask myself, what am I looking for? So when it's asked how old are they, I'm just going to list the quantities that I'm looking for. And I'm looking for Joanne's age and her daughter Stacy's age. So I'm just going to list these: Joanne, age, and then the daughter's age, right? Daughter Stacy, age. Now this is the first step. And the second step, because I have these two quantities and they're asking for their age, the second step, I want to define my variables. So I ask myself, how are their quantities related to each other? So how are these quantities related to each other? Related to each other. Whoops, I can't spell. Sorry. So when I look at this, I'm looking for a direct relationship. And the first statement says Joanne is 22 years older than her daughter Stacy. So we notice that Joanne is directly defined in terms of her daughter Stacy. So if we let her daughter's age be X, then I know Joanne's age is X plus 22. So that's a direct relationship between the quantities. Now, step 3 is a mathematical process that involves these quantities. And you notice here it says the sum of their ages is 42. So whatever I have for my quantities, I know that I'm going to sum their ages, so I'm going to add, and whatever I get, the answer when I add them is 42. So that's the mathematical process. And when I just put these values or the expressions that define the quantities, then I have the sum of Joanne's age and her daughter's age, X, and X plus 22 equals 42. Right, so now I have my equation. I can solve this. So I get 2x, just combining the x on the one side. We'll subtract 22 from both sides, and we get 2x equals 20. Dividing by 5, or excuse me, 2, sorry. Canceling the 2's, we get x equals 10. So that was the solving part. So now step 5. I get x equal to 10, and I'm just going to go back up then, look at my definitions. Well, that means Stacy, which is the daughter. So Stacy is 10, or 10 years old. And Joanne is, and the expression says just take x and add 22. Well, 10 plus 22 is 32 years old. Okay, so going through these steps, what am I looking for? How are those quantities related to each other? And then step 3, what's the mathematical process that involves these quantities? Let's look at a geometry problem. So here we have the length of a rectangular garden is 10 yards less than twice its width. If the perimeter of the garden is 124 yards, find the dimensions, length and width of the garden. So again, first step, I know I'm trying to find the dimensions, the length and width. So we can list these quantities, or with this, I'm going to use the diagram of a rectangle to define my quantities. So maybe this is the width over here, and this is the length. In step 2, I'm asking myself, how are these quantities directly related to each other? And you notice the first sentence, it says the length of a rectangular garden is 10 yards less than twice its width. So the length is directly related to the width, right? The length is 10 yards less than the width. So if we let x equal the width, then the length is. So if we let x equal the width, then how do we define the length? And it says it's 10 yards less than twice x. So 10 yards less than means I'm going to subtract 10 from twice the width would be 2x. So again, I'm using a direct relationship. I know I'm looking for length and width of a rectangle. How are those quantities related to each other? That's where I come up with x and 2x minus 10. And then step 3, what mathematical process involves these quantities? Well, the perimeter of a garden is 124 yards. And the perimeter, remember, P, the perimeter, equals 2L plus 2W. This is a known relationship or formula. So if it's known, we'll just use that. If it's a known formula, we don't have to come up with the relationship. The formula is the relationship. So what we do is we just plug in the values. The perimeter, which is 124, equals 2 times L. Well, L is the length. So this would be 2 times 2x minus 10. That's our definition of length. That's our expression for length. And then plus 2 times the width, and the width is just x, so 2 times x. So if a formula is involved, and that's what I mean, I need to understand when they talk about perimeter of a rectangle, either I can look that relationship up, but that formula is the mathematical process that relates length and width. So I can just plug those expressions that I defined for that. So let's go ahead and solve. So we'll simplify the right side, distribute. We get 4x. 2 times negative 10 is negative 20 plus 2x. If I combine 4x and 2x, I get 6x on the right side. And if I add 20, I get 144 equals 6x. And then dividing by 6, I get 24. So now this is where I need to go back. I got x is 24. So part 5, I'm going to answer the question. So x was the width. So we can say that right away. The width is 24 yards. This is in terms of yards. But how do I get the length? Now the length is the 2x minus 10. So I'm going to substitute in the 24, and the length would be 2 times 24 minus 10. So this is 48 minus 10, which is 38. So now, again, I did some calculation with my value for x, and the width is 24 yards, and the length is 38 yards. And I got my answer. So we could check to make sure that makes sense by just plugging those values in and finding the perimeter. But I'll leave that up to you. The big thing is coming up with this equation. So the most important part is translating our relationships into this equation. So we start off with quantities that are related, direct relationships between the quantities, and then we need to have a mathematical process that involves those quantities. All right, let's do a miscellaneous problem. It says a mountain climber wants to cut a 213-foot rope into 3 pieces where each piece is 2 feet longer than the previous one. How long is each piece? So again, we'll just start out. What am I looking for? Remember, I'm going to list the quantities or draw a diagram. Now, we could draw a diagram to help us with this. Maybe we can draw like a rope. Here's a rope. And we're going to cut the rope into 3 sections where each section is 2 feet longer than the previous one. So you notice I kind of drew them so that the sections were kind of smaller to bigger. So if each section is 3 pieces, well, this rope, remember the total length of the rope is 213 feet. We could put that on our diagram too. But step 2, I need to define each piece, which is all 3 pieces. So I can always base it, it says where each piece is 2 feet longer than the previous one. If I start with X representing the shortest piece, then X plus 2 must be the length of the next longest, and then X plus 2 plus 2, or 4. If I add 2 to X plus 2, X plus 4 would represent the length of the longest piece. All right, so I had a diagram. I got 3 pieces defined with expressions. And now step 3, what's the mathematical process? Well, what do I know about all 3 of these pieces together? Well, the rope that we started with was 213 feet. So the total, if I add up these 3 pieces, I should get 213. So if I add up the 3 pieces, I should get 213. And the 3 pieces that I'm adding up are X, the first piece, X plus 2, the second piece, and X plus 4. So again, we see in this equation, we see the expressions that we defined and the mathematical process that involves those pieces. All right, so let's go ahead and solve this. I have 3 X terms, so we'll combine those X terms on the left side. I get 3X. Notice I have 2 and 4 on the left side. So if I attach a -6 to both sides, that will cancel the 2 and the 4 term. And then 213 minus 6 is a 207. So now when I divide by 3, I should get X equaling 69. So again, you could check that, but I think that's right. So X is 69. So now that I have my answer, I'm just going to go back to my definition so that in step 5, I can answer the question. So we can say something like, well, since these represent the length of the 3 pieces, we could say the pieces are, well, one of them, the shortest is 69 feet. And then if I add 2 to that, I get 71 feet and 73 feet long. Okay, so the next video we'll go through some uniform motion problems where the focus is going to be on kind of keeping all of our information organized.